This is one of the momentum labs, and this is basically the apparatus. We might need some paper in order to level the track better, but we have the two carts and we have the balance, and it's a very observational type of lab. Notice we do have a plunger cart. We're not going to be using the plunger in this, but the reason why I picked one plunger cart and one what's called a collision cart is that there's going to be an orientation where they will repel each other, an orientation where they will stick together, as you will see. And so it requires less thinking later on. So first thing we need to do is find the mass of each of these. So this is going to be the heavier mass, just because I've done this stuff enough. The one with the plunger is a heavier mass, and so that will probably end up being mass 1, but let's just find out officially. So what I'm going to do is pause it and tune back in when we have the balance ready. All right, so we have the plunger cart here. I have it upside down so it won't roll off the balance. And you can see that it's pretty well lined up. Maybe not perfect, but close enough for what we're doing right here. And the counterbalances are, you see the back one's on 10, the middle one's on 500, and there's the close one for you to be able to read. Let's see how close I can get and still keep it focused. Not that. There, probably as close as I can get. So pause it if it's shaking around a bit too much there. All right, so now we'll find the mass of the other one. So there's the collision cart now on the balance, and you can see that it is pretty well balanced right there. And so now let's take a look and see what the mass is. So the back one's on 0, the middle one's on 500, and this one is right there where you can see it. Again, let's see how close I can get. And let's see if I can stabilize that a little bit. There we go. Now we need to figure out how much mass needs to be added. So this is cart 2 right here, and so I'm going to add mass to it till the masses are within a gram of each other. And so I'll just keep adding stuff. I have pennies right here if I need to add smaller masses, and then there's various paper clips and so forth, small things around here that I can add. So I will come back when I have them close enough. All right, so I didn't have to add any pennies, but I did add those 2 paper clips and that 10 gram mass, 10 gram in quotation marks, plus or minus. So there is how balanced it is. You can see the back one's on 10, the middle one's on 500, and this one is about where it was for when we had just the plunger cart. So now let's figure out the mass that I have just added. So finding the mass of the disc there and the 2 paper clips, you can see this is how balanced we are. And the back one is on 10, the middle one is on 0, and there is, there we go. There is the close beam right there. So you got the total mass right there. Hopefully what that is within a gram, the difference between the 2 carts as originally measured. So we're going to put those 3 little masses on top of our cart number 2 so that its mass is now roughly the same mass as my plunger cart. One other piece of apparatus that I left out before was the long load mass. Now we need to find the mass of the long load mass, and that will be used for half of the actual mechanics of the lab. So I will come back when I have that one balanced. So we have the long load mass sitting on the balance. This tells you how balanced it is. And let's take a look at what we have. The back beam is on 0, the middle beam is on 500, and there's the nearest beam right there. Notice that it approximately has the same mass as each cart, off by 12 or so grams there. But considering we're not doing measurements in this lab after we got the masses, that's good enough. The next step is to level the track. And so there's the track in all its glory. Let's come back when we have it leveled. All right, so we put the track on the table, and that gives you an idea of how level it is right there. And that's pretty darn good. We'll put the carts on it and see if they roll without like having to touch them. And that's the bigger test of it. All right, and you'll notice that that cart is moving on its own. It sits still for quite a while, and it could be that the track is slightly warped. Oh, there it stopped. Let's see if we can. All right, so I might add a little bit of paper in order to tilt the track. So I've added a little bit of paper at that end over there, and the cart is not moving on its own anymore, and that neither is that cart. Let's just pull out the level again one more time just to be sure. And that's looking pretty much like it did before, but apparently the little bit of paper was enough in order to keep it from rolling. So we are good to start the experiment. So first thing is we need to make sure we have the right orientation of the carts here. So notice that if I do that, they stick together. So that's not the orientation I want for the elastic collision piece. So I'm going to turn this around, and that is not the right orientation. So I'm going to turn that one around. There we go. Notice that they do repel each other. Two carts of approximately equal masses here. Cart 2 is at rest, and cart 1 I'm going to push towards it. And so this is just observational. Let's see if I can back up here some. All right, hopefully the resolution didn't change too much on that one, but we do have the two carts right here. I'm going to have cart 2 sitting still. Cart 1 is going to be pushed. I'm going to push cart 1 towards it, and we'll just see what happens. That is the first case right there. Second case is we're going to start cart 1 at rest. This is cart 1 again. Cart 1 has the plunger. And then I'm going to push cart 2 towards it. Again, cart 1, cart 2. I am going to have cart 2 sitting still and cart 1 pushed at it at a different speed. So I'm going to first try to do a slower speed, then a faster speed. And then a faster speed. See how fast I can get. What I don't want to have happen is to push it so hard that they hit, because I mean I can overpower the magnets. I can force them together with a big enough push. But I don't want them to touch, because if they touch, then momentum is lost, because you can hear some of the momentum goes into the air molecules, which eventually hit you in the ear. And yes, I know there's no such thing officially as an air molecule. I'm just talking about one of the molecules in the air. Here we go. There we go. And then now I'm going to push them towards each other with unequal speeds. All right, that was probably the best one right there. That's it. Now I put the long load mass onto cart 2, and we go through very similar to what we just did. I'm going to start this at rest, and I'm going to push cart 1 towards it. Not the same thing that happened last time. It's in part 5. It's a different result than we had when the masses were roughly the same. I'm putting this at rest, and I'm going to push cart 2 towards it. Again, a different result with the masses being unequal. Keep this one at rest and push this one at a different velocity. So let's see if I can make it faster. And then slower. There we go. I like that trial. And then towards each other at unequal speed. So first thing I'm going to do is I'm going to try to push this one faster than cart 1, and then I'll switch that. So don't think I did that successfully. So obviously that was the one where I did this one faster than that one. And now let's try the other one where cart 2 is faster. And now I want them to stick together, so I need to rotate one of them, I think, and they will stick together now. All right, so for part C1, part C1, I'm just going to push this towards that. And notice what happens when they join. And then I'm going to try to push them towards each other with equal speeds. This requires some coordination, so I might be doing 10 shots of this, and you'll just see the best one. Now push towards each other with unequal speeds, so I'm going to do this one faster. Rotated this one around, because hopefully it will stick better. And now I'm going to do cart 2 faster. And that's the way it's supposed to work. And then sticking together. All right, so I have cart 2 sitting right here. I push cart 1 towards it. They stick together. Sort of contrast to what happened before. Now my initial speed on cart 1 was not quite the same as it was last time. There's no way I can duplicate that with what I'm doing right here. But and a quick contrast with and then the last one is towards each other with equal speeds. And one more time, equal speeds. Okay, this mass is roughly twice this mass right here. It's not exact, but roughly. And there you go. The rest is you're being able to write it down correctly. It gets a little bit tricky in the wording. Please be careful. Some people talk about the positive direction or the negative direction and never actually specify what's the positive direction or negative direction. Sometimes they refer to things moving in the same direction without providing the same direction as what. So just please be very careful with the wording. And I think that's it. But don't forget, above all, because this is physics, don't forget to rejoice.